This is Charles Lewton-Brain, and this is a short slideshow about making a thermoplastic pitch stick for setting. First of all, I'm taking a broomstick, that's my favorite size, or a dowel that's about 1 inch across, something that's comfortable in the hand, and I'm cutting it to about 6 or 7 inches long. After cutting it, I turn it sideways and cut into the end to create texture and something for the aquaplast, the thermoplastic that we're going to use to bite into. You can use a different saw blade. You're just looking to create texture. And here we are making slits into the end of the dowel. And you can see that we crisscross them. And we also, if possible, create a little bit of texture on the sides of the top. This is a thermoplastic. This one is Aquaplast. It's very similar to Jet Set Basic. And there is also Thermolock. And thermoplastics like this, once upon a time, they were called friendly plastic. You can find multicolored ones in flea markets. And they're also used for lightweight casts at the hospital on injured arms and legs. I'm warming some water up on the left-hand side. Note it's not boiling, it's just warm. And what we can use a microwave to do this. We can use a little electric tea making tool, and when we're ready, we take the thermoplastic beads, in this case Jet Set, and pour it into the hot water. We leave it for a few moments. It's quite fast, and the beads become transparent. When they are pretty transparent, you can fish it out and they will stick together. You can sweep it around and pick up errant beads that are elsewhere in the pot. And at this point it is kneaded. So it can't be too hot. It has to be still comfortable in your hand. And the aim of the kneading is to squeeze out water that might be stuck in between the granules, and to make it into a cohesive mass that is plastic and can be used in various ways. And here we have the mass, and I'm attaching it to our prepared pitch stick like that, and pressing it into the texture, locking it into place as much as possible. There we go, and we can shape it. The Aquaplast or Jet Set stays soft for quite some time, and so we have quite a bit of ability to work with it. One thing we can do is take the mass and roll it between our hands. This makes it uniform, round, and helps you shape it. We can also press the surface onto a flat surface. Steel works best in order to flatten it and shape it. And when we're happy with the shape, we can dip it into cold water or perhaps spritz it with something to cool it. So a heat gun or a hair dryer can also be useful when working with thermoplastics, because it will heat it enough to melt it, but particularly with a hair dryer, is not that dangerous to you. And here I am taking my piece of metal that I want to place onto the pitch stick, and I'm warming it. I can use all sorts of ways of warming it, a torch flame, but not the flame part, just the hot air from it. And again, heat gun, hair dryer works really well. And when we're ready, we test the metal on the thermoplastic. We just touch it, and that tells us how hot the metal is. And you really don't want too much molten. And if it ever smokes, you're just way too hot. Back off. You just want it to melt a little bit, and in fact with this amount of melting I would call that a bit more than I need. Just heat it, press it in, and then dip your fingers in water and use the wet finger or the wet thumb to tighten the thermoplastic around your metal. You can continue to press it in, and when you are ready, when you're satisfied with the smoothness and the way that you can get at everything later, you take it, make sure that it's nice and fixed, and then we cool it again. And here I'm using a water spray to cool it. And here's the finished pitch stick. And it's got the metal sample mounted in it, and it's ready for us to begin flush setting or other kinds of setting. It can be useful if you're going to be drilling holes in your sample plate to mark it all up before you put it into the thermoplastic. And that heat gun is useful for later use, for reworking the thermoplastic into different shapes, and so on. Thank you.